Here's another type of problem you're going to see at some point. Let's say I have an angle right here, and we're supposed to figure out what that angle is. And they give us that this side, let's say this side right here, is 300, and this side up here is 600. Alright, so what is this angle? What is this angle right here? Alright, well, SOHCAHTOA says that if we have a right triangle and we have an adjacent side, and a hypotenuse, we should be able to find this angle using one of these three functions: sine, cosine, or tangent. In this case, we're going to use cosine, because in order to use cosine, we need to have two of the three things. We need to have two of either the angle, the adjacent side, and the hypotenuse. Right now we have the adjacent side, we have the hypotenuse. So we have two of the three things. Sine would not work for this problem, because in order to use sine, we would need to have two of the three things that are the angle, the opposite side, which we don't have, and the hypotenuse. Now we could do some calculations and we could find the opposite side, but I'm like you. Why do any extra work, right? Why take the long way when, in this case, the short way works just fine? Sometimes the long road is the best road, but in this case, we're going to use the shortest way. Same thing with tangent. We could use tangent, but we would need one more thing between the angle, the opposite, and the adjacent. Again, we're missing the opposite and we're missing the angle, so all we would have for tangent is the adjacent side. Doesn't help us. So what we're going to use is cosine, because cosine of an angle equals adjacent over hypotenuse. We have both the adjacent side and the hypotenuse, so cosine of this angle equals the adjacent side, which is 300, and the hypotenuse, which is 600. I can reduce the right side of this equation. I get cosine of an angle equals 1/2. Alright, well, we can look on our sheet, right? The sheet that was given out to us, the note sheet, and you can look up the values for cosine. The values for cosine when it equals 1/2 are 60 degrees. And the other time we get a 1/2 value for cosine is 300. So now we look back at our triangle. Which one of these two values makes sense? Well, you cannot have a right triangle. In fact, you cannot have a triangle at all if you have an angle of 300. So for this problem, this angle that we're looking for right here is going to be 60 degrees, because the opposite, the ratio between the opposite and the hypotenuse is 300 over 600, which equals 1/2. So the only time it logically happens is when cosine is 60 degrees, because cosine of 60 degrees equals 1/2. So the angle we're looking for is 60 degrees. That angle in radians, if we were required to change an angle from degrees to radians, remember, if we go from degrees to radians, we multiply by pi over 180. So in order to change this angle from degrees to radians, we can multiply by pi over 180. 60 goes into 180 3 times, so this angle would also be pi over 3. Alright, that works out nice and neat, and it's also on your sheet, but just in case we get different angles that we need to change from degrees to radians that don't happen to be on our sheet, please remember for the test, hint, how to change from either degrees to radians or from radians to degrees. What would be the formula to change from radians to degrees? Well, it's going to be the reciprocal 180 multiplied by 180 over pi. I hope this helps. Thanks for listening.